When you ask why magnets repel each other, you believe you're posing a straightforward question, but you're not. And until you grasp why your question is fundamentally flawed, every answer you receive, mine included, will leave you unsatisfied. Let me demonstrate the issue. Grab two magnets and bring their north poles together. Notice that push, that invisible force in what appears to be empty space. You're seeking an explanation. You want me to say magnets repel for the same reason as something, then complete that sentence with something you already know. Rubber bands stretching, springs compressing, two palms pressing against each other, something within your existing framework of understanding. But here is what you need to hear. No such familiar comparison exists, and I'm not being evasive or hiding behind scientific jargon. I'm delivering a truth most people refuse to accept. Magnetic forces are fundamental. They represent bedrock reality. There is nothing beneath them for comparison. You're requesting that I explain electromagnetism by referencing something simpler. Nothing simpler exists. It is equivalent to asking me to explain basic arithmetic using something more elementary than numbers themselves. It cannot be done. Right now you're thinking, but I've encountered explanations before. Magnetic fields, spinning electrons, these sound like deeper answers. They're not. They're descriptions, extremely precise, remarkably accurate descriptions. They reveal how the force operates, not why it fundamentally exists. You must grasp the distinction between these two concepts, or this entire discussion becomes meaningless. Let me pose a question. Press your palm against your desk surface right now. Press firmly. Why doesn't your hand penetrate through? Your likely response is because the desk is solid. Incorrect. Not incorrect because the desk lacks solidity. It possesses it. But incorrect because that is merely another label for the phenomenon you're attempting to comprehend. Try once more. Why doesn't your hand pass through? Because atoms are densely packed. Closer. Continue. Why don't the atoms comprising your hand pass through the atoms forming the desk? Because atoms themselves are solid. No, pause. Consider this carefully. Atoms are not solid objects. An atom consists mostly of empty space. If you magnified an atom to football stadium dimensions, the nucleus would be a pea at the center. The electrons would be tiny specks near the outer seats. Everything between is emptiness. Your hand is fundamentally empty space. The desk is fundamentally empty space. So why don't they interpenetrate? You're becoming uncomfortable now. Excellent. You should be. The answer is electromagnetic repulsion between electrons. The electrons in your hand and those in the desk carry identical charges. Like charges repel when you press downward, you're experiencing trillions upon trillions of minuscule electromagnetic interactions, collectively producing what you perceive as solidity. Now here is the question that will genuinely disturb you. Why do like charges repel? You cannot answer that, can you? You might say electromagnetic force. But that is merely assigning a name that explains nothing. It is circular reasoning, like saying magnets repel because of magnetic force. That is not an explanation. The electromagnetic force constitutes one of four fundamental forces in nature. It is not produced by something else. It is not derived from anything simpler. It simply exists. And here is what nobody mentions. The force preventing your hand from passing through the desk surface. That is precisely the same force making magnets push apart. The identical force, not similar, not analogous, identical. The electromagnetic force. So why does one seem obvious while the other seems mysterious? I'll explain why. You've been pushing against solid objects since infancy. By age 2, your brain had accumulated an extensive library of such experiences. Pushing, grasping, falling, hitting surfaces. Your neurons wired themselves around these experiences. They constructed patterns, expectations, an entire intuitive framework. Now, when you push against a desk, it feels normal, natural, self-evident. You don't question it. You don't believe it requires explanation. But magnets exert force across empty space. You observe the gap. You can insert paper through it. Nothing visible exists there. That feels strange. That feels incorrect. That feels like it demands explanation. But here is reality. The strangeness exists in your perception, not in the physics. When you push the desk, the electrons in your hand never actually contact the electrons in the desk. They repel across a distance, a minuscule distance, few atomic widths, but still a distance. We label it contact because the distance is imperceptible. But it is not genuine contact. Nothing touches. It is electromagnetic repulsion operating across a gap. With magnets, the gap is larger, a centimeter, an inch. Large enough to observe, large enough to create discomfort. But the force remains identical. The mechanism remains identical. The sole difference is scale. The mystery you perceive isn't a mystery in the physics. It is a mystery in your psychology. You're comfortable with electromagnetic repulsion at atomic scales because you've experienced it throughout your existence. You're uncomfortable with electromagnetic repulsion at centimeter scales because it is less familiar. That is the entire difference. Now you're probably thinking, surely quantum mechanics explains why the electromagnetic force exists. Wrong again. Quantum electrodynamics. The quantum theory of electromagnetism is the most precisely verified theory in all of science. We've measured certain predictions to 11 decimal places, and the theory matches perfectly. But here is what QED accomplishes. It provides methods to calculate electromagnetic interactions with extraordinary precision. It delivers rules, equations, predictive capability. What it does not do is explain why the electromagnetic force exists in some profound philosophical sense. It describes the force beautifully, perfectly, but doesn't explain it away. It doesn't reduce it to something simpler, because nothing simpler exists. Let me illustrate with a different example. You ask why ice floats on water. I can tell you it is because ice is less dense than liquid water. Why less dense? Because the molecular structure contains more space between molecules. Why that structure? Because of how hydrogen bonds arrange themselves at freezing temperatures. Why do hydrogen bonds arrange that way? Because of quantum mechanical properties of electrons in water molecules. Why do electrons possess those properties? Because of the Scharf-Feidinger equation and Pauli exclusion principle. Why do those equations hold? See what is occurring. At each step, I'm providing a deeper answer, but I'm also merely pushing the question back one level. Eventually, and this happens quickly, you hit bedrock, the fundamental equations, the basic forces. And there, the only honest answer is that is what we measure. That is what the universe does. We can describe it mathematically. We can test it experimentally. We can use it to generate predictions and construct technology. But we cannot explain it through something more fundamental, because nothing more fundamental exists. The chain of why must terminate somewhere. Here is the profound problem with your magnet question. When you ask why, you're not genuinely requesting information. You're requesting comfort. You're asking me to connect the unfamiliar to something familiar, so you can cease feeling confused. You want a narrative, a story, a chain of cause and effect, terminating in something you already comprehend. But magnets repel because of the electromagnetic force, and the electromagnetic force exists because that is a fundamental property of the universe. There is no story. There is no deeper because. There is only measurement and mathematics. I know that is unsatisfying. I know you desire more, but the universe doesn't care about your desires. The universe is what it is. Let me tell you what genuinely bothers me about this question. You're treating magnets as special, as the one anomalous thing in a universe of normal things. That is backwards. Everything is electromagnetic when examined closely enough. Why do chemicals react? Electromagnetic forces rearranging electrons. Why does light reflect off mirrors? Electromagnetic interaction. Why do you perceive colors? Electromagnetic radiation striking your retina. Why does your computer function? Electromagnetic forces moving electrons through circuits. The electromagnetic force isn't some exotic phenomenon appearing only in magnets. It is everywhere. It is the dominant force throughout your entire existence. Gravity. Weaker by a factor of 10 to the 36th power, completely irrelevant for atoms and molecules. The strong and weak nuclear forces, confined inside atomic nuclei, too short, range to affect anything you can touch. Everything else, and I mean everything, is electromagnetism. The force making magnets push apart is the identical force holding your body together right now. The same force preventing you from falling through your chair. The same force enabling you to read these words. So when you ask me to explain magnetic repulsion by comparing it to something normal, you're asking me to explain electromagnetism using electromagnetism. It is circular, cannot be done. Let me attempt a different approach. Perhaps this will help. You know how you can explain the color blue to someone who can see. You show them the sky, a blue garment, you provide examples. But how do you explain blue to someone blind from birth? You can discuss wavelengths, about 450 nanometers. You can describe where it sits between red and green in the spectrum. You can give them all the physics of blue, but none of that conveys the experience, the actual blueness of blue. They must see it. There is no shortcut. Same with magnets. Same with electromagnetism. You don't acquire the intuition from an analogy. You don't get it from a brief explanation. You must work with the mathematics. You must solve problems, make calculations, predictions, test them. After months, perhaps years of working with electromagnetic theory, something shifts in your brain. The equations begin to feel natural, intuitive, obvious. Not because they match your everyday experience, but because you've constructed a new everyday experience, mathematical experience, familiarity with how fields behave. And then magnets aren't mysterious anymore. They're exactly what you'd expect. Inevitable consequences of charged particles and fields. But you cannot shortcut that process. You cannot skip to the conclusion. You must earn the intuition. Now, let me tell you what I can provide. The technical answer. Magnets possess magnetic dipole moments, little arrows of magnetism. When you align many of them in the same direction, you get a permanent magnet. Those dipoles create a magnetic field configuration that stores potential energy. Physical systems naturally evolve toward lower energy states. When two north poles face each other, the energy is high. Moving them apart lowers the energy, so they repel. That is the answer. That is as deep as it goes. You want to know why dipoles create fields. I can tell you about moving charges and electron spin. You want to know why electrons have spin. I can tell you about the Dirac equation and quantum mechanics. You want to know why the Dirac equation is correct. I can tell you it follows from combining special relativity with quantum mechanics. You want to know why those theories hold, because they match reality, because we've tested them millions of times and they work. That is it. That is where the chain terminates. Here is what you need to understand about how physics actually operates. We don't begin with philosophy and derive the universe. We start with measurements. We observe patterns. We write equations describing those patterns. We test those equations against new experiments. When the equations work, when they enable us to predict things we haven't observed yet, we say we understand the phenomenon. Understanding in physics doesn't mean philosophical satisfaction. It doesn't mean matching your intuition. It means predictive power. It means being able to calculate, to predict, to construct technology that functions by that standard. We understand electromagnetism better than almost anything. Quantum electrodynamics is tested to incredible precision. We can calculate the magnetic moment of an electron to 11 decimal places, and the measurement agrees exactly. So when I say I understand magnets, I mean this: I can calculate the force between them. I can predict how they'll behave in different configurations. I can design electric motors, generators, MRI machines. I can manipulate magnetic fields to trap particles or focus beams. That is genuine understanding. That is what physics offers. Not comfort, not familiar analogies, but power. Control over nature. You might not like this answer. You might find it unsatisfying. Too bad. The universe doesn't owe you an explanation that makes you comfortable. It doesn't owe you a story matching your intuition about how things should work. Your intuition evolved to throw rocks, gather fruit, and avoid predators on the African savanna. It did not evolve to understand quantum fields or electromagnetic interactions at the atomic scale. So when physics reveals something violating your intuition, particles acting like waves, time slowing at high speeds, magnets pushing through empty space, you have two choices. You can reject it as mysterious and unsatisfying and keep demanding better explanations that don't exist. Or you can expand your intuition, learn the mathematics, work through the problems, build new mental models based on equations and experiments, not everyday experience. That is what physicists do. None of us found quantum mechanics intuitive initially, but we worked with it long enough that it became familiar. And eventually, it started to feel natural. Not because it matches common sense, but because we built new common sense. Mathematical common sense. Mathematical common sense. So here is what I want you to take away from this. The next time you pick up two magnets and feel them push apart, don't ask why. Ask how. How does the force depend on distance? How strong is it compared to gravity? How can I calculate it? How can I use it? Those questions have answers. Good answers, precise answers, beautiful answers. The one asking for reduction to something more familiar, that question doesn't have an answer. Not for magnets, not for any fundamental force, because fundamental means exactly that. Bottom level, nothing underneath. But here is the beautiful thing people miss when they get stuck on why. What physics reveals is that the universe operates according to a small set of rules. The same equations describing magnets also describe lightning, brain signals, computer chips, the aurora borealis, chemical bonds, why stars shine, why atoms are stable. That is not a failure to explain. That is unification. That is discovering that underneath all the apparent complexity and chaos of nature, there is a deep structure, a mathematical structure, simple rules with incredibly complex consequences. That is what should blow your mind. Not that we can't reduce magnets to something simpler, but that we can reduce thousands of seemingly different phenomena to the same underlying force. You wanted me to explain magnets by comparing them to something familiar, but I'm telling you something better. Everything familiar is actually magnets, or rather, everything is electromagnetism. Same thing, your desk, your body, the air, light, chemistry, life itself. It is all different arrangements of electromagnetic interactions. You're not separate from the magnets. You're made of the same force. So was my refusal to answer the BBC interviewer arrogant. No, it was honest. I could have given him a comfortable lie. Magnets are like springs, or think of magnetic fields as rubber sheets, or whatever would have made him nod and feel satisfied. And he would have learned nothing. Instead, I told him the truth. The question itself was broken. The kind of why he wanted doesn't exist. At the fundamental level, things simply are. And our job is to describe them accurately, not to reduce them to something more comfortable. People hated that answer, called it evasive, called it a failure to communicate. But they were wrong. Sometimes the most honest answer is the universe doesn't work the way you expect. Your intuitions are wrong, and if you want to understand what is really happening, you need to learn a new way of thinking. That is not arrogance. That is respect. Respect for the truth, respect for the actual structure of reality, and respect for you, for your ability to handle that truth instead of needing a comfortable fiction. Feel that invisible push. Now understand. You're feeling one of the 4 fundamental forces of nature. The same force that makes chemistry work. The same force that makes stars shine. The same force holding you together right now. That is not mysterious. That is magnificent. And the fact that we can describe it with equations, test it with experiments, and use it to build technology, that is not a failure to explain. That is what understanding actually looks like.